In this lesson, we will be using the CAP 697 Flight Planning Manual, which should have been supplied to you as part of your course. The CAP 697 is divided into various sections. Section 2 deals with the flight planning data for the single-engine piston aeroplane. As shown here, page 1 of Section 2 shows that the example single-engine piston aeroplane is a monoplane with a single reciprocating engine, constant speed propeller and retractable undercarriage. The aircraft shown here as a matter of interest is a Beechcraft Bonanza. The following pages give the data from which we can calculate the time, fuel and distance to the climb, cruise with different power settings, the range profile, and the endurance profile. These tables and graphs are quite detailed and will require a separate lesson to specifically teach you how to use them. For now though, we will only briefly glance through them. Firstly, now let us turn to page 4 of Section 2, which is entitled Recommended and Economy Cruise Power Settings. On page 4 is the data for the cruise. Notice that manifold pressure is measured in inches of mercury, which is abbreviated to IN/Hg. Manifold pressure decreases as the atmospheric pressure decreases. Therefore, as the aircraft climbs, the throttle must be advanced in order to maintain the manifold pressure. Eventually, there is a height at which the throttle is fully open, and any further climb will cause the manifold pressure to decrease. The aircraft is said to be at full throttle. The heights at which the aircraft is at full throttle are shown in shaded areas in the table. Engine RPM is controlled by the propeller pitch lever. By adjusting the RPM and manifold pressure, recommended power settings can be achieved. These power settings will give different flight planning data, and this data can be found in the various tables as shown. Now turn to page 8 of Section 2, which is entitled Range Profile. On page 8 is the data for aircraft range. Aircraft range is simply the distance flown by the aircraft with a given fuel quantity, whilst retaining its final reserve. Various power settings, as shown on the graph, will allow the aircraft to fly for a certain maximum range, whilst keeping intact its fuel reserves. The range figures are given in nautical air miles, called still air range, which means that the figures have no wind component. These figures will need to be adjusted for wind in order to get nautical ground miles. Now turn to page 9 of Section 2, which is entitled Endurance Profile. Endurance is the maximum time that the aircraft can remain airborne for a given power setting whilst retaining its final reserve. You can see that the graph gives the endurance in hours. Unlike range, wind does not affect endurance, so it is irrelevant here that the wind is assumed to be 0. Each graph and table that you have seen will be dealt with in greater detail in later lessons.